Hi, seventh graders. Today we're going to start approximating square roots. So we've been looking at a lot lately at perfect squares and figuring out those square roots. Now we're going to start approximating where different square roots might lie on a number line and what an approximate value for them would be. And we are not using calculators today, okay? So the first step, if I wanted to try to approximate the square root of 27, first of all, this is an irrational number, okay? It's not a perfect square, so it's irrational. And I'm trying to figure out, okay, so I know it's going to be a never-ending, non-repeating decimal, but I need to figure out now what that is. So the first thing that you want to do is you want to look at your perfect square list and you want to figure out, okay, what two perfect squares will this fall between? And so when you look at your perfect squares, it's going to fall between the square root of 25 and the square root of 36, okay? And so if we go ahead and think of okay, the square root of 25 is 5, the square root of 36 is 6. So first of all, if I just wanted to know the two numbers it's falling between, it's somewhere between 5 and 6. You could even go a little bit closer and say, well, 27's a lot closer to 25 than it is to 36, so that means it's going to be really close to really close to 5, okay? So closer somewhere toward 5 versus the 6, okay? We can also, though, get an approximate fraction and decimal for this, so we can go a little bit farther, too, with this. So we know it's somewhere between 5 and 6, but now let's clarify that a little bit. So to do this, you want to take the irrational number, which is 27, okay? And you're going to subtract the lower perfect square. So basically, if we subtract that lower perfect square of 25, that gives us 2. So it's two units away from that lower perfect square. And then what we're going to do is we're going to then figure out, okay, well, the difference in those two perfect squares that we're looking at, the 36 minus the 25, is 11. So this would be about 5 into 11ths would be one way to approximate it. But let's go ahead and do one step further and go ahead and make that a decimal. So every fraction is a division problem. So to write a fraction as a decimal, we push over the fraction. So I know it's going to be 5 point something. 11, I have my decimal after the 2 there, so 11 can go into 21 time. 20 minus 11 is 9. I can add a 0 and bring it down. 11 is going to go into 98 times. That's going to give me 88. And then actually it's going to go on and on, right? Well, actually this one won't, but this is just an approximation. So it's somewhere around 5.18, which we could round to the nearest tenth and say it's going to be somewhere around 5.2, okay? And so not exactly 5.2 because it's irrational, so it's technically a non-repeating, non-terminating decimal, but somewhere around 5.2. So we're going to do that again with approximating the square root of 135. So we can look and say, okay, well, the square root of 135 is between the square root of 121 and the square root of 144. The square root of 121 is 11. The square root of 144 is 12. So we know it's somewhere between 11 and 12. Now let's try to get a little bit more specific. So first I want the difference between the irrational, the 135 minus the 121. And then down below I'm doing the bigger perfect square minus the lower perfect square. So 135 minus 121 is 14. And then up here we get down here, 144 minus 121 would be 23. So somewhere around 11 and 14/23, not exactly, because again, it's an irrational number. So it's not going to be able to be written as a fraction, but this is just an approximation, okay? If we wanted a decimal version, it's going to be 11 point. And again, we're not using our calculators. This is practice with division. And rounding these to the nearest tenth. So after the 14, I'm going to put a decimal. I can annex a 0. So 23 goes into 140. We're just estimating. Let's see. I know it's got to be, can't be 7, so it's going to be 6. Okay. And then 6 times 23 would be 138, I believe. Okay, so 23 times 6 is 138. I can subtract. I'm going to get 2. I can pull down a 0 there. 23 is not going to go into 20, so that hundredths place there is 0. I could continue dividing, but I'm just trying to round to that nearest tenth. So that means that this is going to be about 11.6. Again, not perfect, okay, but just an estimate. So let's go ahead and approximate the square root of 57. We look and we find the 2 square roots. It's between. I notice it's between the square root of 49 and the square root of 64, which means it's somewhere between 7 and 8. Okay. Again, you could even start looking at, okay, which one is it closest to? So we do 57 minus the lower one, so 57 minus 49, and that's going to give us 8. And then 64 minus 49 would be 15. So somewhere around 7 and 8/15. And then we can go ahead and approximate this decimal too. So 15 is going to go into 85 times. That'll give us 75. I subtract, I get 5. Bring down that 0. 15 will go into 53 times, which is 45. Okay, again, we don't need to continue on right now. We're just going to round to the nearest tenth. That 3 will make that 5 stay a 5. So this is about 7.5. Okay, not exact, but just an approximation. All right, that is approximating square roots. Have a wonderful day.